Yes, welcome to the online class periodic table and how the periodic table has been classified. So children, all of you should remember the modern periodic table, the elements present in the modern periodic table generally arranged based on their atomic number. So modern periodic table consisting of 7 periods and 18 groups. First period is the shortest period because it contains only two elements, hydrogen and helium. Second and third periods are called as short periods because each period have elements, and fourth and fifth period elements are called as long periods because each period in fourth and fifth period, each period contains 18 elements, and the last one, that is sixth and seventh period elements, are called as longest periods. Each period contains 32 elements. And now again, the position of an element in the periodic table, we can easily identify the position of element in the periodic table by knowing the electronic configuration of an element. So what is the meaning of electronic configuration? You know that atom consisting of three subatomic particles. One is proton, neutron, and electrons. You know that protons and neutrons present in the nucleus of an atom. Electrons are revolving around the nucleus. And this is what modern periodic table. Here, the position of the element is always correlated with their electronic configuration. What do you mean by electronic configuration? First of all, what is the meaning of electronic configuration? Electronic configuration is nothing but distribution of electrons in orbits or orbitals. Okay, orbits. Distribution of electrons in their respective shells. That is what we call as electronic configuration. So how to know the position of the element? How to know the position of the element in the periodic table? Listen, you're supposed to remember the electronic configuration. That is, what is the meaning of electronic configuration? Means distribution of electrons in shells. You must remember atom consisting of number of shells. Atom contains KLMNOP shells. Okay, so just this is there is one of the atom. So in this particular atom, nucleus present in the center of the atom. Here in the nucleus, protons and neutrons will be there. Electrons are revolving around the nucleus in a certain path. That path we call as orbitals. KLMNOP. These are all the orbitals. Basically, now we are going to distribute the electrons in this particular shells. That process is called as electronic configuration. For example, sodium has atomic number 11. So if the atomic number of sodium is 11, means you should remember atomic number equals to number of electrons and number of protons also. So here it says that if atomic number of sodium is 11, means number of electrons also 11. Now we are going to distribute these electrons in the shells, orbits. How to distribute? What is the rule? What rules we supposed to follow? So there are a few rules we supposed to follow. Always the electron distribution depends on the formula 2n square, where n is nothing but quantum number. or energy level. Energy level. So energy levels means KLMNOP. The shells itself is nothing but energy levels. Shells itself is nothing but energy levels. Now let us go with the how to distribute the electrons. That is the point. For example, we have a energy levels, that is also called as shells. We have a shells, that is K shell, L shell, M shell, N shell. The energy level n equals to 1 means that is K shell, n is 2, that is L shell, n equals to 3, that is M shell, n equals to 4 means that is N shell. So what would be the maximum number of electrons filled in each shell? So the maximum filling capacity of each shell is always depends on this particular formula, that is 2n square formula, where n is nothing but energy level. If our first energy level, how many electrons can filled by the K shell? So you can place here, in place of n, you can put 1. 2 into 1 square, that becomes 2. The maximum electrons can fill in K shell is 2, and in L shell is 8, and M shell is 18, N shell is 32. So this is what filling capacity of each shell. You should remember the first energy level K that contains a subshells also, that is subshell of K is 1s, subshell of L is 2s and 2p, subshell of M is 3s, 3p, 3d. I would like to draw that here. Let us go with the electronic configuration diagram. If n equals to 1, the main shell is K. And what about the subshells? Subshells means, so main shell K contains one subshell, that is what we called as 1s. 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 Okay, 1s. Next, L is the next shell. This has the subshells of 2s, n equals to 2, 2s, 2p. And if n is equal to 3, its name of main shell is M. It has subshells of 3s, 3p, 3d, and n equals to 4. N is the main shell, that I can write like 4s, 4p, 4d, 4f. The same way, if n equals to 5, then this is 5s, 5p, 5d, 5f, 5g something you'll get. In the same way, 6s, 6p, 6d, 6f, 7s, 7p, 7d. So enough. This is what is the orbital. This is the diagram. This is the int. You have to remember how to write the electronic configuration. But now you're supposed to remember K fills maximum 2 electrons. That fills in where 1s. S subshell can fills maximum 2 electrons. S can fills maximum 1, 2. Minimum is 1. That means only 2 electrons fills in K shell. L can fills 8 electrons totally. So 2 subshells are there, 2s and 2p. You already learned that S can fills 1 to 2, and remaining electrons out of 8, 2 already fills in S subshell, means 1 to 6 electrons can fill in P subshell. So here 1 to 2 electrons in S, 1 to 2. So all I can write, and 1 to 6 in P. That means 1 to 6 in P. So M can fills, this can fill, K can fills only 2 electrons. This is 8, this is 18, this is 32. Correct now? Now 1 to 2 electrons fill in first shell, that is 3 shell, 3s. 2 to 6, 1 to 6 electrons in 3p, and remaining electron out of 18, 8 here fills means 10 electrons fills in D, and 1 to 14 electrons fills in F. Should remember this particular concept. So this will be the electronic. It helps you to write a proper electronic configuration for the elements. Okay, and this electronic configuration helps to indicate the element belongs to which block in the periodic table. Okay, now what you supposed to do means we should fill the electrons. So electrons always fill shell nearer to the nucleus. This shell is the nearer to the nucleus. So after filling this electron in first shell, that moves to the next shell. So next shell means next sub shell, like this it fills. After this it moves to the next sub shell, that is 2p. After 2p it goes to the 3s. After 3s it goes to the 3p. After 3p it will not goes to the 3d. The electron will jump to the 4s, because 4s energy level is more compared to the 3d. So after filling 4s it goes to the 3d and fills electrons and goes to the 4p. After 4p electron will not jump to the 4d. Electron directly goes to the 5s. After filling 5s it goes to the 4d. After 4d it goes to the 5p. After 5p it goes to the 6s. 6s, after 6s it goes to the 4f, 5d, 6p, 7s. After 7s directly goes to the 5f, 6d, 7p, like this. So this is the way how to fill the electrons in the electronic configuration, electrons in these shells. Okay, so let us go now with one example. For example, I would like to write the electronic configuration of potassium, whose atomic number is 90. So let us write the subshell electronic configuration. Potassium is the element. Potassium is the element metal. It contains 2 electrons in first shell. So why? Because the electrons, total 19 electrons are there. Electrons are 19 are there. Out of 19, 2 electrons fills in first shell. What is the first shell? 1s. I would like to write here 1s. What is the capacity of that shell? 1 to 2 electrons. Maximum how many electrons it can fill means 2. So I can place here 2 electrons, comma. After filling 2 electrons, out of 19, 2 electrons filled in first shell. After filling 2 electrons in first shell, the remaining electrons jumps to the next shell. What is the next shell? L shell. L shell has 2 subshells, that is 2s and 2p. 2s, S can fills maximum 2 electrons, P can fills maximum 6 electrons. Because of 19 electrons are there, so S and P completely fills. So still electrons are remaining. How many? 9 electrons are remaining. Now the electron after filling 2p, it jumps to the 3s. After 3s, it fills 2 electrons in 3s. After 3s, it will go to the 3p. Yes, 3p, it fills 6 electrons. Finally, it remains only 1 electron. There is a 1 electron. That electron, just remember, that electron, look at here, after 3p, electron comes directly to the 4s, directly to the 4s. So it left over the 3d, it leaves the 3d, just it jumps to the 4s. How many electrons still remaining? Here it is 2, here it is total 8, here it is total 8, 8 plus 8 is 16, 16 plus 2 is 18, still 1 electron has to be remaining. So that electron fell in the 4s shell. So this will be the electronic configuration of the particular element, that is potassium. Now look at here, the outermost electron filled in which subshell? S subshell. Hence the reason 19th potassium belongs to S block element. S block element, that belongs to S block. What is that? S block. What is the meaning of S block? Look at here. This particular first 2 periods we call it as S block elements. And these two are here from 20, sorry, group 3 to group 12, we call them as transition elements, and also we call them as D block elements. And here from 13 to 18, we call them as P block elements. And these two, that is what inner transition elements, that is lanthanide series and octanide series, we call them as F block elements. F block elements. Why? Because the distribution of electrons, it is based on the blocks, I mean classification of periodic table in terms of blocks, F block, P block, S block, D block. So this classification is based upon the type of orbitals into which the last electron of an atom of an element enters. So atom of an electron enters. Orbitals into which the last electron of an atom of element which enters. So that is the point. Okay, so now let us talk about the remaining, a few more examples. Let me give you. Okay, so I have given one. Now I would like to take one more example. For example, look at here. So let me take let me take 27, atomic number 27, which this element belongs to which block of the periodic table. Atomic number 27. Atomic number 27. Listen, atomic number 27, that is cobalt. Atomic number 27, that is cobalt, CO. So let me write the electronic configuration. How to write the electronic configuration? 27 electrons are there in the CO. First, we should fill the electrons in first shell. What is the first shell? 1s. How many electrons it fills? 2. 1s2. 2s2, 2p6. After 6, it goes to the 3s. So after 6, it goes to the 3s. So I can write 3s2. After 3s, it directly goes to the 3p. After 3s, it directly goes to the 3p6. After 3p in the same shell, 3d is left. We are leaving that left. I mean, we are just leaving that 3d. After 3p, it goes to the 4s. I would like to write 4s. How many electrons? What is the maximum filling capacity of s? Means 2. After filling electrons in 4s, after filling electrons in 4s2, that will go to the next 3d. The remaining electrons goes to the 3d next remaining electron goes to the 3d. Count the number of electrons already distributed now. Here 2 plus 2 4 plus 6 10 12 18 20 electrons already distributed. 20 electrons already distributed. The total number of electrons present in cobalt is 27. The D can fills 1 to 10 electrons. Remaining electrons in cobalt is 7. That 7 electrons fills in 3D. That means the last electrons, valence electrons, which enter to which subshell? D subshell. Hence it belongs to D block element. Hence cobalt comes under D block elements. Okay. Next, one more example. Let me take. For example, example of phosphorus 15, atomic number 15. Let me write the electronic configuration. That is 1s2, 2s2, 2p6. Next 3s2, 3p. Look at here, count the number of electrons. Total electrons present in phosphorus is 15. 2 electrons fills in first shell, 8 electrons fills in second shell, and remaining should be 2 plus 8 is 10. Remaining is 5 electrons are there. 2 already filled in 3s. remaining is 3 fills in 3p. This will be the electronic configuration for the phosphorus. Look at here, the outer last electrons fills in a p subshell, hence the reason this belongs to p block. This belongs to p block. Phosphorus is a p block element. Is it clear? So the elements whose atoms receives the element whose atoms receive the last electron in the s orbitals means then that belongs to s block. The elements whose atoms receives the last electrons in the p block means that belongs to p block elements. The elements whose atoms receives the last electrons in d orbital d orbital means that belongs to d block, f orbital means that belongs to f block elements. I hope it's clear to you. So let me take one more d block elements or f block elements. Let me take lanthanide elements. We'll write for electronic configuration for lanthanide. Okay, this is what lanthanide. I would like to take cerium 58, atomic number 58. 58 cerium. How to write the electronic configuration? So I am telling you this belongs to the f block element. So how it belongs to the f block element? Let us discuss now. Okay, let us discuss now. Look at here. First, I supposed to write here electron. I supposed to distribute the electrons in each period. That is 1s2, 2s2, 2p6, 3s2, 3p6, 3d. We should not supposed to fill any electrons in 3d unless the 4s2 fills. Okay, after filling 4s2, because of 58, no, after filling 4s2, the remaining electrons go to 3d. That is what 3. Okay, so that is 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d. Okay, just a minute. Okay, let us I'll tell you. Yeah, let me write here. Okay, let me write here. That will help you very well. Okay, cerium atomic number 58. Listen, 58, atomic number 58, cerium. First it fills in 1s2, fine. Next it will go to 2s2, 2p6, fine. After 2p6 it goes to 3s2. Next 3p6. After 3p directly goes to the, after 3p directly goes to the 4s2. After filling 4s it comes to 3d. I can write 3d here, 3d, and after 3d it directly goes to the 4p6. After 4p6 it directly goes to the, after 4p6 it directly goes to the 5s2. After 5s2 it comes to the 4d10. I'll write 4d10 here. And after 4d it goes to the 5p. No. After 4d it goes to the 5p. Yes, after 5s I can write here 5p6. After count the number of electrons, 2 plus 2, 10, 10, 18, 28, 30, 40, 46, 48, 48, 48 plus 6, 48 plus means 44. After 5p it goes to the 6s, 6s2, 44, 45, 46 now, 46. After finishing here, total number of, count the number of electrons, here 2, here total 8, here total 6 plus 8, 8 plus 10, 18. Now 4s, 4p, 4d. I don't know, we should wait for the electronic configuration.